Welcome back to section 3 of chapter 4. In this section, we're going to be looking at solving systems of equations by elimination. Now, this is very similar to substitution because it gets done the exact same thing. It just goes about it in a slightly different way. Now, one of these ways isn't necessarily better than the other. It's just sometimes the system is set up for substitution, sometimes it's set up for elimination. So it is beneficial to know both methods. And towards the end of today, we will look to see what we would look for to see which is the better method. So our learning targets for today is I can solve systems of linear equation using the elimination method. So what is the elimination method? Our goal for the elimination method is we are going to add these two equations together to eliminate one of the variables. It turns out that you can add equations together and it doesn't actually change things. So, if we just take these two equations and we add them, what's going to happen is we have x plus 2x equals 3x, y plus negative y goes away. It's eliminated. That's by design. That should always happen. Equals 7 plus 2 is 9. So 3x equals 9. That's one equation with one variable. We can deal with that. We divide by 3 to get x equals 3. Now that's not our answer. Remember, a solution to a system of equations is a point. It needs x comma y. So we need to pick one of our two equations and plug this back into that equation to solve for y. I would pick the easier of the two. In this case, it looks like the top one. So x equals 3, so we'll have 3 plus y equals 7. And we can subtract 3 to get y equals 4. So our answer, x was 3, y was 4, so we have 3 comma 4. Remember, it's always x comma y. So that's the basic idea. I've got two problems here for you to try. Try both of them. Even if you make mistakes, even if you're not entirely sure, give it a shot. No one's going to know how you did except for you. We'll go over them after you're done. So the first one, we have 2x minus 4y equals 2, and negative x plus 4y equals 3. So you're going to add those together to eliminate the variable, solve for what was left, and then plug it in to get the other one. All right, make sure you have paper and pencil. You're going to need it today. So go ahead, pause the video, solve this using elimination, and then push play when you're ready to start again. All right, how'd you do on this one? Let's add these two together. So we have 2x plus negative x is just 1x. Negative 4y plus 4y goes away. It's eliminated. That's by design. Equals 2 plus 3 is 5. So x equals 5. We need to plug this in. It doesn't really matter which one we plug it into. I'm going to choose the bottom one in this case. So we have negative 5 plus 4y equals 3. Well, the parentheses aren't really needed, so that's negative 5. So we can add 5 to get 4y equals 8. Divide by 4 to get y equals 2. But again, our answer needs to be in the form of an ordered pair because it's a point. X comma y, so that's 5 comma 2. How'd you do on that one? It's pretty much the same as the first one that we were looking at. If you made a mistake, did you see what you did that was not so good? If you didn't, do you now kind of see more what we're doing? We have another one. We have lots of practice problems today. So there's another practice problem here. We have 2x plus 3y equals 1, negative 2x plus 2y equals negative 6. You're going to do the same thing. Add them together. One of your variables will disappear. In this case, it'll be the x's that disappear. Doesn't matter. You'll find the y's first, plug it in to find the x's. So go ahead, pause, do the problem, and then push play again when you're ready to go. All right, so let's see what this looks like. So when we add these together, the 2x plus negative 2x goes away. That's eliminated. It's 0. So 3y plus 2y is 5y equals 1 plus negative 6 is negative 5. We can divide both sides by 5 to get y equals negative 1. And then we can plug this into either of them. In this case, I'm going to choose the top one for only because there's more positive numbers there. So there's less of a chance of making a mistake with a negative. So 2x plus 3 times y, which was negative 1, equals 1. 3 times negative 1 is negative 3. So we can add 3 to both sides. And that gets us 2x equals 4. Divide both sides by 2 to get x equals 2. Now our ordered pair, remember, is x comma y, so in this case it's 2 comma negative 1. Even though we found the y first, the ordered pair is always x comma y. So this is the basic idea behind solving by elimination. We add the two equations together with the intent of one of our variables being eliminated, leaving us with one variable and one equation. Well, it's not always set up perfectly for that. For instance, here, if we add these two equations together, we're going to get 3x plus 5y. One of our variables doesn't get eliminated. So there's a step before adding them together. First, we need to make sure that one of our variables is going to have the same number in front of it, except one's positive, one's negative. In this case, we could take the x's and we could turn both those values into 2. One of them is positive already. We could turn the other one into a negative 2. And we could do that simply by multiplying this top equation by negative 2. Now when we do that, we have to multiply the whole top equation. Every single piece of it needs to get multiplied. We could have chosen to turn the y's into 6's, a 6 and a negative 6. In that case, we would have to multiply both equations by something. We can do it. It works out just fine. In this case, we could have actually divided that bottom equation by 2 or negative 2 to make the x's 1. I'd usually stick to multiplication and not division, because division can get into some fractions pretty quickly, and that just makes the problems more complicated. So when we multiply this top one by 2, and I'm going to put it right underneath this other one, we're going to have negative 2x, and then negative 2 times 3y will be minus 6y. Negative 2 times 7 is negative 14. Now we're ready to add these two together. 2x plus negative 2x goes away. It's eliminated. Again, that's by design. 2y minus 6y is negative 4y equals 6 minus 14 is negative 8. Now we can divide by negative 4, divide by negative 4. So we get y equals 2. Plug that into one of the equations. Now we actually have 3 equations to choose from. I would not choose that bottom one because it's just bigger. Like there's no, it's the top one only, the numbers are bigger. I would choose one of the 2 originals. In this case, I would specifically choose the top one just because that's easier. So we have x plus 3 times y, but y is 2, equals 7. So we have x plus 3 times 2 is 6, equals 7. And we can subtract 6 from both sides to get x equals 1. So our solution, x is 1, y is 2. And we can plug these into either equation and see that it is actually true. So this is just like the ones we did on the last slide, except that we have that step in the beginning where we have to multiply to make sure that the one of our variables will eliminate. We need the values to be the same in front of one variable, but one of them's positive, one of them's negative. So I have another one for you to try. So try this one. It's going to be very similar to the one we just did. X plus 2y equals 4. 2x minus 5y equals negative 1. All right, so multiply to get one of the variables to have the same number in front. I'd recommend the x's just like we just did. And then solve. So go ahead and pause, do the problem. When you're ready, come on back and push play. All right, so just like what we just did, multiply by negative 2 because we have a 2x there. So when we multiply that, we'll end up with a negative 2x minus 4y equals negative 8. You have to remember to make sure to distribute it to the entire equation. Now we're ready to add these. So 2x minus 2x is 0. It's eliminated by design. Negative 5y minus 4y is negative 9y equals negative 1 minus 8 is negative 9. We can divide. And so we are ending up with y equals negative 9 divided by negative 9 is 1. Let's plug that in. So we have x plus 2 times y, which is 1, equals 4. 2 times 1 is just 2, so we can subtract 2, and we get x equals 2. So our ordered pair, x comma y, is 2 comma 1. How'd you do on that one? You could have gone the harder way and multiplied the top equation by 5 and the bottom equation by 2. It would have eliminated the y's first, and you could have solved for x. You'd get the exact same thing. All right? How about another one to try? So we have 2x plus y equals 2, and x minus 2y equals negative 5. Here, you can pick which of the two variables you want to eliminate here. They're going to be basically the same. So do you want to eliminate the x's first or the y's first? It's your call, but go ahead and push pause, do the problem, then come on back when you're ready. All right, which one did you choose to eliminate? It does not make much of a difference here. I am going to choose to eliminate the y's first, so I'll multiply by 2. The only reason why I would choose y's here is because one's already positive and one's already negative. So I don't have to change the sign. I don't have to distribute that negative. That's one less thing for me to make a mistake on. So when we distribute this 2, we end up with 4x plus 2y equals 4. Now we're ready to add these together. So x plus 4x is 5x. Negative 2y plus 2y is 0. It gets eliminated. Negative 5 plus 4 is negative 1. We can divide by 5 to get x equals negative 1/5. Or you could write that as negative 0.2 as well. So from here we can plug this into either of them. Let's plug it into the top one. So we have 2 times x, I'm going to go with negative 0.2 in this case, plus y equals 2. 2 times negative 0.2 is negative 0.4, plus y equals 2. And we can add that 0.4 to get y equals 2.4. So, and if we are questioning this, we can always plug it into the other equation. Negative 0.2 minus 2 times 2.4 would be minus 4.8. Negative 0.2 minus 4.8 is negative 5. So that works out. So let's go negative 0.2, comma, 2.4. And that's the answer for that one. So these can come out to be decimals or fractions just like any other one can. So this is the basis. We can use it to solve problems as well. So here we have a florist is making regular bouquets and mini bouquets. The florist has 118 roses and 226 peonies to use in the bouquets. How many of each type of bouquet can the florist make? So a regular bouquet has 5 roses and 11 peonies, and the mini bouquet has 3 roses and 5 peonies. So we could use x and y. We could let x be the number of roses and y be the number of peonies. But there's really no reason to use x and y unless you're graphing. So we could let r equal the number of roses No, except we're looking for how many types of each bouquet. So we're not actually looking at number of roses here. We're looking at number of types of bouquet. So we need regular. So R is the number of regular, and M will be the number of mini. So not roses. It's the number of regular. And M is the number of mini bouquets. And now we're going to have 2 equations. We're going to have a rose equation, and we're going to have a peony equation. So the rose equation, each regular bouquet has 5 roses. So if we take the number of regular bouquets times 5, we'll get the number of roses that are used. So 5 times regular bouquets, plus each mini bouquet has 3 roses. So 3 times the minis is going to be the total number of roses, which is 118. And then we also have the peony equation. So the regular is 11, so we're going to have 11R plus the mini is 5, so we have 5 times the number of minis equals, and we have 226 peonies. So now in this equation, we're going to have to multiply both equations by something in order to get them to be the same number. So I'm going to first just rewrite my equations. We're going to have 5R plus 3M equals 118, and 11R plus 5M equals 226. And now we can pick which variable we want to eliminate first. We could eliminate the r's first. We could turn both a 5 and an 11 into a 55 by multiplying by 11 and 5 respectively. Or we can turn a 3 and a 5 into a 15 and eliminate the m's. That's by multiplying by 5 and 3, which sounds like smaller numbers than 5 and 11. So we're going to go with that. We're going to work on eliminating the m first. So to do that, we're going to need them to have the same number. So let's make the top one 15. So we'll multiply everything by 5. And let's make the bottom one a 15 or negative 15. We do need to change the sign on this. So negative 3. So when we multiply by 5 on that top one, 5r is going to be 25r plus 15m equals 118 times 5. Some quick math is 590. And then multiplying the bottom one by negative 3, we'll have a negative 33r minus 15m equals 226 times negative 3 is negative 678. Now we're ready to add these two equations together, because the 25r minus 33r will give us negative 8r. The m's get eliminated, equals 590 minus 678 is going to be negative 88. Then we can divide by negative 8, divide by negative 8. And so we get r equals 11. Now it is important that this came out to be a positive number, because if it was a negative number, we ought to look at it and think, well, we can't have a negative number of regular bouquets. So positive is good. Now we can plug this into either of the two. I'm going to go with the top one, just because, again, the numbers are a little bit smaller. So let's go 5 times r, which is 11, plus 3m equals 118. 5 times 11 is 55, plus 3m equals 118. Let's subtract that 55. To get 3m equals 118 minus 55 is 63. Then we can divide by 3, divide by 3. To get m equals 21. So what this tells us is that the florist can make 11 regular and 21 mini bouquets. Putting this one as an ordered pair doesn't really make sense because, well, we didn't use X and Y, but even if we did, we could have chosen either of them to be that. When you have a word problem, write your answer as a sentence or a phrase. That'll ensure that you use units and you put it back in context, which can be important. I know that one of the questions that sometimes comes up is, couldn't we, instead of multiplying by 5 and negative 3 and then adding, couldn't we have multiplied by 5 and 3 and then subtract the 2? The answer is yes, you can. However, I strongly advise against it, because what I have seen is that you'll subtract the first one and maybe the second one, but by the time you get to the last one, that thought of subtraction sometimes disappears, especially if you have other negatives in the problem. That's why I always recommend, and I always do myself, is I make sure that the signs are opposite and then I just add them. It does keep you from making mistakes. So, how do we choose a method of solving? Well, let's take a look at a couple problems here. So, we have two problems. We have y equals x plus 13 and 2x plus 7y equals 10. And then we have 8x minus 2y equals negative 8 and 5x minus 4y equals 17. So, what's different between these two? In the second one, both of them are in standard form. We have the x and y's on the same side of the equal sign, which, if you've noticed, has been the case for every single problem we've done today. You want the x's and the y's on the same side of the equal sign. The first one, we already have y equals. It's solved, like the y is solved for us. That one's set up for substitution because one of our variables is already solved. So for that first one, I would use substitution. The second one, if we wanted to use substitution, we would have to get one of the two variables by itself. Now, we could get the y in that top equation by itself without too much trouble. We'd move things over, divide by 2, and we could get y equals something fairly pleasant. But that's not always the case. In fact, look at that second equation. Getting either x or y by itself is going to be irritating at the very least. And so that one is definitely set up for elimination. The first one set up for substitution. So we're going to solve it first using substitution, and then I'll show that you can solve it using elimination as well. And you do get the same thing. I'm not going to bother with that second one using substitution. But here we have y equals x plus 13. We're going to plug that in for y in the other equation. So we're going to have 2x plus 7 times y equals 10, but instead of y, we have x plus 13. Now we can distribute, so we have 2x plus 7x plus 7 times 13 is 91 equals 10. Add, so 2x plus 7x is going to be 9x. We can subtract that 91. So we have 9x equals negative 81. Divide both sides by 9 to get x equals negative 9. Now we can plug that in. I'd plug it into that top equation. Y equals negative 9 plus 13. So y equals 4. So we end up with negative 9 comma 4. If we wanted to use elimination on this one, we would first have to get the variables to the same side of the equal sign. So that would be subtracting x from both sides. So we have negative x plus y equals 13. And we have 2x plus 7y equals 10. Now we're going to have to multiply by a number. Being that the x's already have opposite signs, let's just multiply by 2. We could multiply by negative 7 and eliminate the y's as well if we wanted to. But we multiply by 2, so we end up with negative 2x plus 2y equals 26. We can add these together. The 2x plus negative 2x goes away. 7y plus 2y is 9y equals 10 plus 26 is 36. We can divide by 9 to get y equals 4. Now we can plug that into one of them. Say negative x plus 4 equals 13. We can subtract 4 to get negative x equals 9. And then multiply by negative 1 to get x equals negative 9. So, once again, we got the exact same answer. Notice it takes almost the same amount of work. This one took a little bit extra because we had to get it set up for elimination. There are some questions where it really does not matter which way you use. It's going to be the same either way. But this one was a little bit easier with substitution. Now let's look at that second one and choose elimination. So first we need to multiply to get our variables with the same number. So in this case I would choose the y's because I can turn that negative 2 into a positive 4 pretty easily. Just multiply by negative 2. That gives us negative 16x plus 4y equals 16. We can now add these two together. 5x minus 16x is negative 11x. Negative 4y plus y is eliminated. And 17 plus 16 is 33. Now we can divide by negative 11 to get x equals negative 3. Plug that into one of them. Let's plug it into the bottom one. 5 times negative 3 minus 4y equals 17. 5 times negative 3 is negative 15. Minus 4y equals 17. We can add the 15. So we get negative 4y equals 17 plus 15 is 32. Divide by negative 4 to get y equals negative 8. So we have negative 3 comma negative 8. So that is more practice solving them, but also figuring out which method do you want to use. So here's a couple equations. Choose a method. One method will probably be easier in either case. Choose a method and solve. All right, go ahead. You have two problems this time. So, and these are the last two. Go ahead, pause the video, do the two problems, and when you're done, come on back and we will look at them. All right, so for the first one, did you choose to use the elimination method? I would choose to use the elimination method here. You don't have to. You could solve for x or y, specifically x in that top equation, without too much trouble. But it is set up for elimination. Now, which variable did you eliminate? It really could have been x or y in this case. For x, we multiply by -2. For y, we'd multiply by 6, both in that bottom equation. Being that -2 is an easier number to multiply by than 6, that's what I'm going to choose. So we're going to multiply by -2. So -2 times 3x is -6x. -2 times -2y will be plus 4y. Equals -2 times -27 is positive 54. Now I'm going to rewrite that top equation down here just so that they're next to each other when we add. That way I don't have to worry about looking at skipping a line or anything like that. So far it's worked out that we've always changed the top one, and so we just wrote it underneath. So adding them together, -6x plus 6x is eliminated. 4y plus 12y is 16y equals 54 minus 6 is 48. We can divide by 16 to get y equals 3. Now we can plug that into any of the equations. I would choose that second equation because the numbers are just a little bit smaller. 3x minus 2 times y, which is 3, equals -27. 2 times 3 is 6, and it's minus 6, so we can add 6 to both sides. So we get 3x equals -27 plus 6 is -21. Divide by 3 to get x equals -7. So we have -7, comma 3. And you can always plug that into the upper equation to check your answer. For the second one, probably using substitution, set up for substitution. We could add the y over and then multiply if we wanted to, and we could use elimination, but let's use substitution. So we have x equals 6 minus y, so let's plug that into the top one. So we have 3 times x, which is 6 minus y, minus 2y equals 38. Distribute, 3 times 6 is 18, minus 3y minus 2y equals 38. We can subtract the 18. So -3y minus 2y is -5y equals 38 minus 18 is 20. Divide by -5. And we get y equals -4. Plug that in. I would plug it into the bottom one. X equals 6 minus -4, which is 6 plus 4, so x equals 10. So we get 10, comma -4. And so that would be solving it using substitution. Those are the two methods that we use algebraically. If there really wasn't much of a difference between the two, like if it's a problem where it's a toss-up, it really is a toss-up. Substitution generally takes a little bit longer to get that first answer, but then the second answer is really quick. Elimination, you get the first answer quicker, but then it takes just a little bit of work to get the second part of the answer. But it does work out to be the same if it doesn't matter which one you choose. So this is the last part of the chapter that we're looking at because we already looked at the last. So we're solving systems of equations algebraically, focusing on elimination this chapter, but there are times when you will want to use substitution. So I will see you in class, but until then, keep working problems, keep asking questions, and as always, happy mathing.